Okay, so this is part 3. Um, we're gonna go over string and string methods. Um, but yeah, no. So I think we've seen a lot of the string methods. But essentially, string methods are used to manipulate strings within variables. So, for example, if I want to make everything uppercase, I'm going to use 2 uppercase, and if I want to make everything lowercase, I'm going to use 2 lowercase. But there's many more to this. So for example, there's one called substring, and it allows us to break strings into pieces. So, um, essentially, think of every string with has an index, and with the index comes the letters. So, if you look at um, the index 0, you'll see the first letter. And if you look at the fourth index, you'll see the letter E within this example. So obviously, there's lots of things you can do with substring. You can look for initials. You can look for you can capitalize certain letters. Um, but yeah, no. So for example, so if we were to look for the space, right? So index of space. So you can see the space within these apostrophe marks. If we look for space, um, name.index of space, it will probably return the number 5. And 5 will be stored within space. So then that means we're able to find the first name and the last name between the space. So for the first name, it is equal to name.substring 0 to space. So if we take a substring from the name, we can go from 0 all the way up till space, till 5. So this is the first name. Then if we do name.substring space plus 1, um, then we can see space plus 1, which is 6, and then everything else. The reason we haven't added, so here you'll notice we did 0 comma space, and here we did space plus 1 with nothing after the comma, because there is no comma, is because we automatically assume it's just the rest of the thing. It's the rest of this string. So it's just space plus 1, and then it's the rest of it. So we don't need to add that extra comma and that extra letters, because it'll just continue. So it's literally working like that. So it'll be name.substring 6, and it will be anything after 6. So this is one of the ones. So JOption pane.show input dialog. It shows name to uppercase. You can find the index of the space. Then you can do from 0 to the space. And obviously this helps you find your first name, your surname, and then the space in between. So if we look at exercise 1.4, and I'm going to pull up JGrasp because I never actually did this in NetBeans. Let's go. Yeah, I think there we go. So here you'll notice that all we have to do, we get the name, then we find the initials. That's all. So what are we going to do? So you'll need to declare some string variables. So we mentioned earlier, so private and public, that's who can access it within the program. That's kind of confusing. You don't have to do that for now. Private, it just means it's local, but skip that. As for the rest, we declare the name as a variable and we call it a string because that name is always a string. And then obviously when we find the initial of the first name and the surname, we can just use char because char, if you remember in our data types in the first part, we talked about how char is only one letter. And for initials, you only need one letter. So that's fine. And then for space, obviously when you try to find the space, you're finding the index, and the index is an integer. So you have to find it. So the space is declared as an integer because the space is technically just an index, and an index is always an integer. So is the name length. So the length of the name is also an integer. It's because it's a number, right? These two are numbers. They're not actual like space. Like they're not actually a string. Um, anyways, so looking into our method, we see public void get names. So name is equal to jOptionPane.show input dialog, enter first and last name. So all we have to do is we have to enter our first and last name into the show input dialog. Fine. Then name and name.toUppercase, so you uppercase the name. That's fine. We've seen it before. Space is equal to name.index of space. So we looked at it just earlier in the example. We find the index of the space. We find where is the space within the string, and it will give us a number. So maybe the space might be at 6. Okay, that's fine. So since we only need the initial of the first name, we can just pick the first index number, the first letter, which is 0. So if I write Carter's name, and I start with C, C is index 0, is the number at is 0 on the index. So you can just find the character at that index, right, which would be C. So all you have to do, it tells you to look at the name and then look at the character at this index starting from 0. Now, if we look at surname, we just look at name dot character at space plus 1. So we will know that, okay, they've probably written their surname after the space. So what is the first letter after the space? It's probably their surname initial. So we just have to write space plus 1. That's the index right, and that's the index number right after the space. So it's the first letter. Then, if we look in our next method, it's just print out. So you just print it out. Your initials are our first name and surname. These two are stored as strings, as we can see up there. String and they're stored as chars. And yeah. So the next part, so these are obviously a bunch of these methods. So char add just basically finds what character is at specified index. Another word for index is position. You need to the number that goes in has to be an integer, and the output will be a char or a car. I really don't care. Compared to you just compared two strings in dictionary order. Compared to okay, I don't actually know too much about this. Compared to ignore case, um, if you ignore um, capital letters, then you compare the two strings in dictionary order. Then if you look at concat, which is short for concatenate, um, you just you add a string to the end of another string. So if you say first name, then you add and you do dot concat, you'll add the last name. So obviously the input has to be a string, and the output will obviously be a string. Then contains just checks if a string contains a certain string. So if this newspaper article contains the letter and the word hi, so obviously the input has to be a string. It has to show what you're containing. And then what the output will be is actually a Boolean, because you're going to see if it's true or false if this string contains the specified characters. So it might be true, does contain it. It might be false, it doesn't contain it, fine. Ends with just checks if a string ends with the specified characters. So like shun, which is a suffix. So obviously the input has to be a string, and then the output comes with a Boolean. It just checks, okay, is it true or is it false? Does it end with this or not? Then equals just means it just checks if two strings are equal. Obviously, it's true or false if they're equal or not, and the input obviously has to be a string. Then if we look at equals ignore case, compares two strings, ignoring case considerations. So you just compare two strings without looking at capital letters. Then index off, this is useful. You look at the position of a character within a string. Um, so what is the index of p in some string? And it will return to you an int. It will return to you a number. So it's at this position. It's at the third position, whatever. Remember, the index starts at 0. Then the last index off, it just finds the last found occurrence of a specified character in a string. And then if you look at length, it it shows you how long a specified text is. It's obviously the input's a string, and then the output's an integer, it's a number. And then replace, replace first, replace all. And they all have the same idea, just different orders. It searches the string for a specified character, and then returns a new string when the specified values are replaced. So obviously this has to have at least 2 characters, and then the output's usually a string. Split a string into an array of substrings. So we haven't really gone into arrays. I'm pretty sure that's a grade 11, but until then, this will stay like this is. It's literally just almost like splitting different strings and by some sort of delimiter and then followed by the limit. Then starts with, so because by the way, this comes into an array, by the way, the output of the split. Then starts with just checks if a string starts with a certain letter, string, boolean. Obviously the input's a string and then the output's a boolean, checking if it's true or false. Then the substring, we've already been over that. And then to lowercase makes the text lowercase. To string, it returns the value of a string object. You don't actually put anything in, but it returns a string. Same things for these two, you don't put anything in. So to uppercase, it just makes the letters uppercase, it comes out as a string. Then trim means it removes white space from both ends of a string. So if I type in like this, hello. So you'll notice I actually have a little bit of white space at the start and the end. So that's what trim does. It actually removes that from the ends of strings. Then if we look at data types, we've actually already been over this, but we're just going to go over it one more time. Integer or whole numbers, double or real numbers, Boolean is true or false, character is one single character, and then all of these take a certain amount of bits. So int is 32 bits, double is 64 bits, Boolean is 1 bit, and a character is 16 bits. These are different examples. We're declaring and initializing it. These are class headers and method headers, so you're obviously showing the difference between a class header and a method header. Sorry. So a class header, obviously it's public class, and then the class name. Then a method header, it's public void, which is the return type, which means it's returning nothing. Get names, which is the name, and then there's no, and then for now we're not using any arguments. I'm not sure about next year though. And then obviously these can differ. So I think if you remember from the term 2 pad, it was actually we actually used protected for lots of these class headers. Then the method can have a return type. Right now we're just using void. And then sometimes a method can have arguments or parameters, which can be used within that method. And now we're on to date and time. So date and time, so essentially it's just another object, date and time. So obviously these two are more libraries. Remember, JOptionPane is not the only library out there. There's plenty more with many more features. So local date and local time actually come with 2 different libraries. And so now what we're going to do is let's say we want to get the local date and the local, let's say we want the date and time now, and we want to put it in a variable. So all we have to do is we have to put local date.now into the date, which is the name. We have to put local date before it. So that's actually its data type, if you can call it that. That is the data type of these of these date and time variables. It's called local date and local time according to the library. These are how they are outputted. Um, and then we look here, so this can obviously be used in many ways. You can use it like, okay, we don't want you to, we'll make something invalid before 8 a.m. There's many things you can do. You'll see it later. Then in conditional statements, it's all about making decisions. So using the if statement, else statement, you know. So an if statement actually chains with an else statement. And if there are multiple if statements, then they're all standalone. The else is the actual chaining part. So let's see here. If the price is bigger than 100, then discount will equal 50. So if the price is bigger than 100, which could be true or false, then the discount has to be 50. It's pretty simple. Then the second option, if the total is bigger than 500, then the discount has to be 50. If the total is bigger than 1,000, then discount has to be 70. If the total is smaller than 500, then the discount has to be 50. Otherwise, if that's false, then the discount has to be 70. Otherwise, by the way, is else. So else basically means if all of the above are false, then else will be true. So if total is bigger than 500, then discount will equal 50. And otherwise, if the total is bigger than 1,000, then discount will equal 70. So um, if total 500, if this first if statement executes, then this will never execute, right? But if this is not true, then this might be true. Otherwise, these two also have the ability to be false. They both have. So that's the thing about adding else if. That also has the ability to be true or false. So you can actually read it in this text here. So if both the conditions are false, then both will be none will execute. Okay, I think my mic's back. Okay, moving on. If condition 1 is true, then so if this condition is true, if total is bigger than 500, then discount will equal 50. Otherwise, if the total is bigger than 1,000, then this line will execute. Otherwise, if the total is bigger than 2,000, then this line will execute. So obviously, total has to be 100, and discount has to be 100 if the total is 5,000, because they've skipped past these two, and only this one's true. So obviously this can differ. One may be true and the other may not be. If this is true, by the way, if the middle one is true, then the third one becomes false. Moving on. Um, these three if statements are all standalone, right? So they don't actually interact with each other. If total is bigger than 500, discount will be 50. If total is bigger than 1,000, then discount will be 70. If total is bigger than 2,000, then discount will be 100. So these are all standalone if statements. They're not together. Then obviously you can use different string methods and number methods. So here you can say if house dot equals ibis, or if house dot equals cormorant, if house dot equals kingfisher, then this can happen. So obviously these dot equals tests if the house, which is the variable, which is the string, is the same as the string given. Then if it is equal, then this will be, and then this line will execute. Otherwise, if it's not equal and this is also equal, then this line will execute. If that's not equal but this is equal, then this line will execute. Otherwise, if none of those are equal, then the last one will execute, which will just say unknown. So it obviously says here we use equals when comparing string to see if they are the same. Then obviously if they can be changed to, if this can also apply to numbers, right? Um, this can, yeah, no, it can also apply to numbers. So if the number is equal to 10, remember, we use equal equal when comparing numbers to see if they're the same. And we use one equal when we have to add data to a variable, right? So we can't say number equals 10 because now the number variable will equal to 10. It won't be, but we're not trying to achieve that. We're trying to see if they're the same, if 10 is the same as the number given. Um, then, um, so obviously same thing. If this is true, the if and else if and the else all work the same way. This is a program showing like the date and the time and the name. So, your date and your time, and if the name is the same as the name provided in the variable, then it'll grant you access. So that's a program they've given as an example. Now, I think I have done this. Discount. Yes, I have. I have. How wonderful is that? Um, okay, so here it shows if loyalty cards that begin with S are granted a 10% discount. If they start with C, then it's a 7% discount. If it's a number longer than 5 characters, then they get a 12% discount. If it's otherwise, every other loyalty card gets a 5% discount. Um, it's just a really simple if and else statement thing. So if you see here, we've created two variables, um, the card number and the discount. Um, so obviously the first method we'll talk about how we'll make sure the user enters their card. This could also actually go into the constructors method. So don't get me wrong here. This can actually we can change that to discount manager and then remove the void. So that actually becomes a constructors method. Um, yeah. So then if we look in the card check, we check what the card has. If the card number If the character at the index of 0 in the card number is equal to S, then the discount will be 10%. Then we apply this to every single else if statement, and then we get our answer. So if the card number length is bigger than 5, then the discount will be 12%. If the card number character at C is, if the first letter of the card number, because we see car at 0, then it will be 7%. Otherwise, if all else fails, then the discount will be 5%. Then obviously it will print it out, system, your loyalty card number is this. Yeah, yeah, yeah. So we can just try and run this. Whoops, wrong one. NC.enter card. Oh, yeah, yeah, yeah. I forgot about the constructors method. My bad. Okay, there we go. So C bara 7%. Done. So yeah, there we go. That works. Now, if you look at 1.5b, they ask us to print out the date and time. It's pretty simple. All you gotta do is, let me just find it. It's OP. I really hope I've done this specific one. I don't think I have. Oh no, I have. Okay, cool. All we have to do, we have to declare the date and the time. So local date is .now, local time .now. Obviously we have to import these libraries, and then we assign these specific data to the variables, and then we can use it later when we have to print it out in the final line. So that's that. Um, I can show you running it. What was one of the conditions? If boom. Okay, my thing is 12%. That's my loyalty card number, and that's the time I redeemed it. Do not redeem it. Anyways, and then there are different conditions we can actually use. We don't just have to use equal equal. We can also use not, and or. So and requires two things to be true in order to be true. Not requires things to not be equal so that it is true. and or can be like one or the other can be true in order for the if statement to be true. So you can see here, if value is not equal to 7 and the value is bigger than 10, it will be true. If the value is bigger than 10 or the value is smaller than 0, then it will be true. If the name is Steve and the password equals to 123, then it's true. If the total is 100 or the prize awarded is false, then it is true. So these are different operators we can use. I think we've learned them in the Boolean logic thing, in like I think it's chapter 6 or 7. 6, 7. And yeah, no. Then moving on to date and time. So obviously you can specify a date that you want, right? So it doesn't just have to be like dot now. So you can do local time off 8 a.m. 6:20 p.m. Remember, it works in an hour. Remember, it's a 24-hour system. Hour, minute, and second. If I can select it, that would be very nice. Hour, minute, second. Same thing for all of these. Some of them may not work because it's not allowed to. So like this one says 24, 0 minutes and 1 second. You can't have the 24th hour. That just becomes midnight, so that just turns to 0. Um, then if same thing with the date, local date dot off. Remember, this is the data type. Um, it works in year, month, and day. And yeah, no, it just gives you all of them. You have to make sure they don't exceed the wrong amount of days. So you can't say like, the 31st of February. Um, so this is a nice example. So for date and time, you can learn the first three. So this is our first three date and time and methods. We can see if it's before. So these all return Boolean. So they check if it's true or false. So you can check if the time is before, or it's after, or it's equal to the time given. So um, people may not log in before 6 a.m. in the morning. So that's one thing you can do. So obviously here you can show local time, valid time, that's the name of the variable, local time dot off 6 a.m. And if if the name is equal to my name and the time is after valid time, which is 6 a.m. If the time is and the time is after 6 a.m., then access will be granted. Else, name or time condition is not met because the access is denied. I have done 1.5C or 1.5D, but they work pretty similarly. So for here, you would just have to use like time. The time is after, and you just have to use an if statement to make sure they can't redeem it before 8:30. Uh, and yeah, no, it's pretty much it, I think. Yeah. So good luck. And that's it for the handbook.